193, guys. We're going to talk today about equivalent ratios or learning goals, drawings to model and determine equivalent ratios, reason about T diagrams to model and determine equivalent ratios, defining rates and rate reasoning. We actually won't get to that part today. We'll continue that for next time. We're going to talk also next time about scaling up and scaling down and the double number lines. So we're going to do the first 2 of the 5 for today. We're going to do a quick review. We want you to circle the correct statement to complete each sentence. We're going to start with the basis of it takes 5 workers to paint 3 houses in a day. 5 workers to paint 3 houses in 1 day. So given that baseline information, they're giving you a couple more situations, see which way you think it needs to go. Our first one, they're painting 2 houses with more workers. So it's going to take what? Less time. But I'm doing more houses in a shorter time. What kind of reasoning were we using for those? Okay, your journal entry, guys. What type of thinking is that? Qualitative. This is qualitative thinking. Any numbers involved? No. It was a slide of numbers. We're just reasoning, thinking about that is qualitative reasoning. That makes more sense for everybody? Okay, let's go to our next page. Consider the given representations, answer each question, explain your reasoning. So they've given you 3 different situations. And then for the 4th one, what type of reasoning? Additive or multiplicative? That's going to make a big difference in how you are thinking about these. So go ahead and work together at the table. They've already given you the model. We'll give you guys about 4 minutes to figure this one out. Make sure you're explaining your reasoning. Okay, our first one. Which dinner order has more pizza?
They have also I prefer burgers.
Okay, that's interesting. They have the same. Anybody have something different? Okay. Yep. That's the same answer. I asked you to have something different. Max?
Order 2 because like if you have order 1, it has too many burgers in it. What do you want? So what is it? For dinner, I ordered more pizza.
Look at it. What is it? 5. This is 4. Which one is 4? So as a ratio, order 2 has more.
So
Got it. The whole concept that we're trying to get to you we're doing. If you are just using additive reasoning, if I'm just looking at them, this would actually be correct. I would say, well, if I'm using multiplicative reasoning, if I'm looking at the ratio, this would be correct. The order 2 has more. Wow. What did number 4 ask? So your type of reasoning and what answer you got. Okay, what about for pattern 1? Which one has more? Okay, so pattern 1 has more. What if I look at ratio reasoning? 4 out of 6. One is 3 out of 5. Which one is higher? Which is higher? 4 out of 6. What?
Yeah.
Which one's higher? 4 out of 6 or 10? So in both cases, pattern 1 is higher. Okay, which pile of shirts has more shirts? Pile 1 or pile 2? Okay, so they are equal. Why not?
Because pile 1 is 2 out of 5. Yeah.
So, as a ratio, pile 1 has more. So again, this is down to how are you thinking about it? So are you just looking at it? Additive reasoning shows that they're the same. Multiplicative reasoning will show the ratio is looking at the ratios. We're extending it out. Okay? Let's go to our next page on 195 now. Harry and her friends are going hiking. You should invite your friends to meet at her house for a quick breakfast before heading out. She wants to offer yogurt. She knows that one yogurt pack has 4 yogurts that can feed 4 people. So we just gave you some examples on some models. Here's your directions. We need to draw a model, question, and then explain our reasoning. So they've given you 3 different problems. Because you're going to need to draw a model, I know this is going to take you guys a little bit longer. We'll give you guys actually 8 minutes. So it'll take 8 minutes. Work through the 3, make sure you've drawn your model, and then you explained your reasoning for giving your answer. Everybody clear on what we're doing? First one. What is the relationship between a yogurt pack and the number of people that will feed? Accurate.
I played these games.
Okay, so that would be 1 pack, 2, 4 people. Our model would look something like this. I've got a pack of 4 and 4 people. My artistic skills make Miss Fiorucci very jealous. Yeah, next one. Okay, everybody's 5 minutes. How many yogurt packs does she need? Question?
And what? People need 2 packs.
Pack. Our model would look something like this. I would need 2 packs for 5 people. I don't know what all the chatter is. I'm talking now, you're not. If you have a question, you raise your hand.
They needed 2 packs because if you just had one, it only like there'll be 1 person left.
Okay. So 1 pack would be 1 person left with nothing. Technically, if she counted herself, it would leave 2 people with nothing. There's nothing in the pack, or if you said there would be 3 extra yogurts or 2 extra yogurts, so she's eating 1 as well. Okay, if Carrie has 2 3/4 yogurt packs, how many friends can she feed? She can feed 11. Okay, what about our model? Our model should look something like this. I have 2 and 3/4 packs and 11 people.
Why don't you straw person and then put a lot of stuff?
That is model. 6, 7, 8, 9. Understanding what's going on here?
Yeah.
Okay? Guys, I'll be honest, this is why I don't like models. It's a lot of work. But the models help you to get the concept. And that's what we're working on right now, is understanding this concept that as one side is changing, my other side changes as well, correct?
Yeah.
Okay, so as we're looking at these, let's go to our next page. Now we're going to do a variety pack. So if I do a variety pack, 2 out of every 5 yogurts are blueberry. So again, they're asking you to draw a model to answer each question and explain your reasoning. So it's much the same as what we just did. Again, you've got 3 problems. So let's go ahead and work on those 3 problems. All those answers. Because you are going to need the models as well. We'll give you guys another 8 minutes to do this one. So go ahead and start working. First one. How many yogurts are blueberry yogurts? A total of 25. So given our initial size, you've got 2 to 3. That gives me 5. So I need to do another set. That brings me up to 10. Another set brings me up to 15. Another set, 20. And another set, 25. So now I know I have 25 yogurts. How many of them are blueberry? 10. So there are 10 blueberry yogurts. Explain our reasoning? No. What's my reason? What? Okay, so I would make my answer easy on this one because they made me do the model. And the model showed the answer. What?
The model.
I'm sure you don't think the model answer?
That is totally to be bold.
And I did. I stated the model, the answer. Hey, how many yogurts are blueberry? There are a total of 35. So basically all that we're doing now is taking our same model, 2 to 5, and now instead of just 25, we're drawing 35. So how many sets of them am I going to end up with? So how many sets of models am I going to end up with? 7. So if I have 7 sets of models, there's 4, 5, 6, and 7. How many blueberries did I end up with? So 14 blueberries. My model of the answer. one of the cumulative tests, you should be a little more expansive on that and say, by the time I do 35 total, I got it up and 14 of them were blueberry. How many total yogurts are there when 8 yogurts are blueberries? Now I'm kind of going the other way, so I'm still going to keep drawing the model, but now I'm just going to keep drawing until I get 8 on the blueberry side, which is 4 times, but what is my question?
How many total?
Okay, so I know that once I've got 4 models, I've got my 8 blueberries. And how many total do I have? What? How many total blueberries do I have? 4 sets of 5, correct? 4 sets of 5 means how many total yogurt? 20. So there are 20 total yogurt. 4 sets of 5. So you need your marking pencil. We've got a couple of definitions for you today. Our first one is equivalent ratios. Equivalent ratios are what we just did. An equivalent ratio is ratios represent the same part to part or part to whole relationship. It sounds like most of you are done. So our first one, blueberry to totals, it's going to be 3 blueberries. What was our total? 6 total. What kind of ratio is that? Part to whole. Our next one, pumpkin. 2 pumpkins. To 6 total. Our total didn't change. What type is that? Another part to whole. Our next one, brand to total. Brand was 1 brand. 6 total. What type of ratio is that one? Part to whole. Our next one, blueberry. 3 blueberry. 2 pumpkin. That one is a part to part.
You have to say
All right, next one, brand. So again, it's 1 brand. 2 pumpkin. Again, a part to part. And our last one, blueberry. Blueberry. 1 brand. Someone just said my brain is going to writing part of brand. Okay, here's another definition. Please quiet down. Especially on our recording days. So our next one, a tape diagram. A tape diagram is just another form of modeling that illustrates number relationships by using rectangles to represent ratio parts. I will be honest, I was never taught tape diagrams when I was in school. So the first time I was teaching them, I was like, I don't know what this is, and I skipped it. And then it came back for like 4 straight lessons. I'm like, well, maybe I should teach myself this. So I taught it to myself, and after I started learning it, I was like, this is actually kind of cool. But it's a lot easier way for us to be able to take larger ratios and be able to model them. So rather than having to do all those pictures like we were just doing, if you're asking for a model, tape diagram is my preferred way to model these ratios. The whole key on a tape diagram is that a tape diagram, we always our simplest form of the ratio. So we've been talking about the equivalent ratios, once are the same. Rather than going all the way out, our tape diagram will always use the simplified version. This one is a ratio of each type of muffin. What does each small rectangle represent in our model? What do you think? So for example, in the blueberries, there's 3 rectangles. Pumpkin, there's 2, and the branch, there is 1. So what do you think each rectangle represents? Good job. Each rectangle is 1 muffin. One muffin. How many total muffins are represented? 6. Because there's 6 boxes. So take diagram, we're taking our ratio, simplifying it, and making 1 box for each part of the ratio. So when we're looking at the whole thing, now we can talk about equivalent ratios. What if I did an 18 pack of muffins? How many blueberry, pumpkin, brand muffins will be purchased? Well, we know there's 6 muffins in the tape diagram, but I want 18 total muffins that are in this ratio. So to determine how many muffins I need to maintain the same ratio, I can divide 18 by 6. When I do 18 divided by 6, I get 3. So what we do is we take that 3 to show that there are 3 sets of total 18 to get to that 18 total. So each part gets 3. What that now means is 3, 6, 9, there are 9 blueberry muffins. 3, 6, there are 6 pumpkin muffins. And 3, there are 3 brand muffins. Does that make sense for everybody? So here's the one thing that when I was teaching myself how to do these tape diagrams, drove me crazy. Because technically there is no math word for that number. So I made up my own math term to help us be able to discuss it. So I want everyone to write this definition down. What we're going to call that number is a ratio constant. Okay? So the ratio constant is the number that goes inside a tape diagram to show equivalent ratios. Here's the biggest thing on the ratio constant. Once I get my ratio constant, every box in my tape diagram gets that number. If I have different numbers inside the boxes, I messed up. In the tape diagram, every number must be the same. That number we will call is the ratio constant. So when we're doing these types of problems, one of the biggest things you need to be able to do is figure out what the ratio constant is. They have to give you enough information to figure it out, or you can't solve the problem. Now, one of the big pieces on this is you have to be able to determine what they've given you. So if they told me just the pumpkin number, what would I divide it by? Figure out my ratio constant. 2. So if I said there were 18 pumpkin muffins in the packages, I would divide it by 2. My ratio constant would now be 9. What if I said there are 12 blueberry muffins total? What's my ratio constant?
36.
No. 12 blueberries. How many boxes are there for blueberries? 3. So that means my ratio constant would be 12 divided by 3 is 4. You have to be a ratio constant of 4. If I said there were 24 muffins, in the package? What is that? Is that a blueberry? Is that a pumpkin? Is that a brand? What is that? Total. So now I'm looking at a different number. I said there's 24 in the package. Well, that's a total. How many total muffins are in my tape diagram?
I just have no idea.
Talking about the tape diagram. And now we figure out our ratio constant. How many muffins are in the package, guys? 6. So I would take my 24 and I would divide by 6, which would give me a ratio constant of 4, meaning every box would get a 4. Does that make sense? We'll do a couple examples towards the end of this to help you understand it. Okay, let's talk first though. Is the ratio 9:6 to 3 equivalent to 3:2 to 1? Or is it equivalent?
Yes.
Actually, don't look very confident.
I have 2 answers.
Are they both yes? They could be. Oh, yeah. Let's multiply. 2, 1 by 3. I get definition. As long as a constant number goes between those ratios, they are equivalent. Mason, what are you doing? You're definitely not paying any attention or writing down anything I've written up here. Okay, as we're now going to use the tape diagram and the ratio constant philosophy to try to answer number 4 and 5. Again, they have to give you enough information to figure it out, and they have. You just have to be able to put together the information they've given you to figure out what your ratio constant is. We'll give you guys about 3 minutes. It's one of those you just kind of get or you don't. That's the whole concept on this ratio constant. They have to give you enough information to figure it out. In this case, it's a 36 pack of muffins. So what we call a total, right? So I have to look at my total boxes. How many boxes do I have? 6. 36 divided by 6 is a ratio constant of 6. Meaning every box gets a 6. The whole idea on the ratio constant. Okay? So now I say I have 3 6s, that means blueberry. 2 6s means one little pumpkin. 1 6 means there's 6 grams. So how many blueberry muffins will I receive? I will receive 15 blueberry, 12 pumpkin, and 6 bran muffins. Does everybody see where I got those numbers from? Anybody not? Maybe a better question. Okay. Our second one. Suppose that you wanted 20 pumpkin muffins in your variety pack. How many total would I have? One of the easiest ways to do these tape diagrams, guys, is put that information right on it. So I know it's 20 pumpkins, correct? So 20 pumpkin, I've got 2 boxes. What's my ratio constant? 10. Once I find my ratio constant, every box gets my ratio constant. So that means there are now 30 blueberry, 10 bran. But what's my question? How many total? So what is my total? There are 60 total muffins. Are you starting to see how these go together? Because unfortunately, this is not all they give us on the tape diagrams. So we're going to go off of that. Now, given that concept, though, we have a table that shows the number of muffins in special size variety packs. Complete the missing cells for just the 6 and the 36. So I want you to fill this out and this out. We'll come back to it. So I'll give you 1 minute. Bell rang a little early, so everyone's going to do this because we did it with the first period. So on our first one, we're just going over basics. It was a 3, 2, 1. And then when we go to the 18, I can just double this. We'll follow by 2. So use 18, 12, and 6. And then the rest of it we'll talk about is next time we have class. Remember your grade, your homework for the day will end up being math. You want to go for the second and 34th. Good luck, guys.